Assalamualaikum warahmatullahi wabarakatuh. My name is Hamdan Shakiri BMMU. In previous semester, I had read some news about some small machine that can produce good quality product in short time. So I choose this interesting project as one of the technology that allow user to use more easily and quickly and provide a new generation in the technology industry. So today I would like to present my project Sarjana Muda, and my title project is Development of Visual Component Technology Based CNC System for ISO 6983 Data Interface Model. So in this project, have an introduction which is including background, problem statement, research objective, and scope of research. Background. This project is about developing the machine control system by utilizing visual component-based technology to execute the ISO 6983 data interface model on 3-axis CNC milling machine. First point, the computer numerical control, which is CNC machine, are based on a method that employs mini computer to create, interpret, and execute sequential control. Second point is, most important component of CNC is controller, which is made up of software and hardware. Third point, the interpreter is the controller software component that convert the International Standard Organization, which is ISO, data interface model instruction to hardware instruction. 4. A few of the major factors that contribute to CNC technology: economy, reliability, fast production speed, product uniformity, lower component depreciation, reduced replacement part cost, less operator interference, and ease of convoluted form machining. The 5 point is, CNC machine use the ISO 6983 data interface format, also known as G-code. The 6 point is, the CNC controller software module, also known as an interpreter for ISO 6983 data interface model, will be discussed in this study. There are second major point in introduction, which is problem statement. There are few points of problem statement in this project. The first point is, the G-code is a low-level language that primarily specified in terms including its cutter motion location and feed rate. And the second point is, CNC machine tool systems that are supplied as a black box by control suppliers, making it difficult for machine tools builders to quickly develop and implement new or customized control function. The third point is, existing ISO 6983 based CNC system convert data in a single direction, resulting in no feedback response. As a result, shop floor modifications are extremely difficult to carry out. Research objective of this project. First, to develop a 3-axis soft CNC motion control system for a 3-axis milling machine incorporating visual component to execute ISO 6983. Second, to integrate development system using a 3-axis CNC milling machine to implement the production method. And the last one, to test system experiments to be used to validate the production framework. Scope of research only influences the motion of 3-axis milling unit, and only a window-based problem has been addressable. And the last one, just operate with the GRBL controller, which appear to be able the hardware using G-code. Literature review. There have few major elements of CNC machine. First, input device. Second, machine control unit, which is MCU. Third, machine tool. Fourth, driving system. Fifth, feedback system. And the last one is display unit. These are the type of CNC machine: CNC laser cutting machine, CNC lathe machine, CNC milling machine, 3D printer, and CNC plasma cutting machine. 3-axis CNC milling design. This machine was designed in small concept of 3-axis CNC milling. Some of hardware was chosen in this project: adapter, sliding bearing, nut holder, screw rod, power wire, spindle motor, power supply, stepper motor, and support system, which is our laptop. Type of G-code in CNC machine. G-code, commonly known as RS-274. G-code command are sent to a machine controller which instruct the motor on where to go, how quickly to move, and which part to take. In general, these codes are give instruct to a machine such as quick movement, for example, move the tool as fast as feasible between cut. Second, accurate fit in a straight line or an arc. The third one, a sequence of controlled fit motion that result in a hole being bored, a component getting cut and routed to a specified dimension, or a profile being inserted toward the edge of a workpiece. Fourth, configure tool data include offset. And the last one, change the coordinate system. ISO 6983 Data Interface Model. This section of ISO 6983 helps in the coordinate of device design in order to reduce the number of program manuscripts needed, facilitate uniformity of programming techniques, and encourage interchangeability of input program between numerically operated machines of the same classification by type, operation, features, scale, and accuracy. Serial interface connector include RS-232, RS-422, and RS-423. It is important to note that all of changeability required at the CNC data interface will also be implemented in the computer system if meaningful communication are to take place. CNC software controller. The figure shows where the GRBL fit into the big scope of a CNC machine operation. First, G-code must done by user then send it to Arduino. It is a firmware that must be installed or uploaded to the Arduino in order for it to operate the CNC machine stepper motor. To put it another way, the GRBL firmware job is to transform G-code into motor function. GRBL software for Arduino. GRBL is free open source software that was created as motion control for an Arduino microcontroller board, allowing an Arduino to be used to operate CNC machine. The GRBL controller is software program to send G-code to CNC machine such as 3D milling machine. The Arduino Uno is a microcontroller board that utilizes the ATmega328 microprocessor. G-code interpreter code written in C is flashed into the microcontroller board. Inside of LabVIEW. In this project, LabVIEW are chosen as visual component. Laboratory Visual Instrument Engineering Workbench, known as LabVIEW by National Instruments, is widely used as a control software development tool in both academic and industrial. LabVIEW is a programming environment that features a dataflow-based VPL called Zero, designed to facilitate development of data actualization, analysis, display, and control application. Software is divided into two parts by LabVIEW, a block diagram as well as a user interface, which during LabVIEW is called the front panel. Methodology. The figure shows flowchart of this project. The project starts with an initial inquiry and background study on existing research to fill the research gap, establish the aim, importance of study, and addition to be body of knowledge. The scope of study is to focus on the CNC motion control system for a 3-axis milling machine that incorporates visual component in order to complete ISO 6983 for this project. The knowledge acquisition of the CNC system for ISO 6983 data model interface and other relevant information is gathered from published journal, conference paper, thesis, book, and white papers. The figure shows the Gantt chart which illustrates the project process flow. In the summary, the purpose of this project was to develop a 3-axis soft CNC motion control system for a 3-axis milling machine incorporating visual component to execute ISO. This project only influenced the motion of a 3-axis milling unit and just operate with the GRBL controller, which appear to be able the hardware using G-code. The project design focused on a small CNC, which is a small CNC milling machine. This shows that this project can improve the quality of the machine, the need to reduce human error, reduce wastage, and maintain high quality and precision are some intrinsic properties driving the potential volume of CNC milling machine. That's all from me. Thank you and Assalamualaikum.